Good morning. All right, give everybody a minute to get in, set up. All right. Looks like it's going to be a light showing today. All right. So I'll go ahead and say we are going to be doing one thing that's a little, adding one thing in, it's a little different. So this is for the purposes of keeping attendance and that sort of thing. So as soon as you guys get in to the channel, after the meeting starts, go to the group chat and just put a message that says here or present, or it can be something silly, whatever you want. That way I have a timestamp and your an official copyable record, just in case I miss something or forget to add somebody's name later. That way I have, yeah, exactly like that. That way I have a copy of it, because the recordings don't copy the participants. So yeah, we're going to do that. And then also sometime toward the end, with like 5 minutes left or so, if you could also give a farewell or something. And that way we can That way we can have everything just nice and streamlined. Okay. So first thing of note is we have, good morning, a test currently up on WebAssign. So there are, again, 2 tries of it. Don't start the one try, don't start a try until you are ready to proceed, because it will close out on you. It will start that timer, and you'll be kind of out of luck if it goes away. So make sure don't open it up until you're ready, and then that will close Friday at 5 p.m. And so even if you do well or pretty well on the first one, and do the second one, it won't, even if you bomb it for some reason, it doesn't take away anything from that first grade. Like I said, I just take the highest of those 2. And then there you go. So yeah. All right, we will get started.
So what do you so what we gonna take the test at again?
So let's see, where's my share button? So the test is right here. It says Math 111.3, test 3, try 1, and test 3, try 2. So those are the 2 tests. You just take it online. And it looks just like a normal homework, but it is timed. That's what this little hourglass thing right here means. So you do not have to do both tries. I would suggest you at least do one of them. But if you do well on that first one, and I don't know, say you get like a 95 or something, then no. I mean, the other try is there if you think and you want to try to do better. But no, it's definitely not required that you do both. But please at least do one of them. Preferably get a passing grade on one of them. But it's just under your normal assignments. And like I said, don't open it up unless you are ready to go. Good questions. All right, any other questions about the tests? So all the rules for it are up on e-learning. Go to my class, go to resources. There's a little thing that says online tests. So you can go there, and it will and it has an outline of all the specific rules for taking those. Tells you that it's timed, and tells you how much time you have, tells you how many tries you get per question, kind of thing. So refer to that if you've got any questions before you start. All right. So we had been talking about these glorious things called functions. These are things that you have, whether you realize it or not, dealt with in the past. And the most common function that we've dealt with is, let me Not forget to share my screen back. Most common function that you've dealt with is just the graph of a line. Y equals mx plus b. And that kind of looks like a 6. Sorry, as always. It's a little better. All right. So this is a function. You have an input, x. Just put something in for x. And then the slope and the y-intercept act on it, and you get out at the end a y. So this is y is a function of x. So another way you could write this is f of x equals mx plus b. So we had, this is where we start. Let's actually put in some numbers here just for giggles. 2 and, I don't know, 3. So what is so what are we going to do with this information, I guess, is the first question we've got. Well, first thing we talk about is evaluating a function. So if this is f of x equals 2x plus 3, what does it mean when I write f of, let's say, 2? What does that mean? Anybody? No? Okay. Well, so this is a function of x. So whenever you have anything inside of here, after we have already defined what f of x is, all you do is you take that function f, and everywhere you had an x, you put a 2. So this becomes 2 times 2 plus 3 equals 7. So this is known as evaluating a function. For those who came in a little late, please remember, so what we're starting off today is you need to make a comment on the chat as soon as you get into the meeting. So if it's a question or something like that, that's fine. But if you don't have a question or anything yet, you can just write here. So that way I can keep track of who got in when, that kind of thing. And the same thing a little bit before the end of the meeting. So just make sure you do that at some point. Okay. Well, this is evaluating a function. Okay. So it just means that you take some function that you've already been given, f of x equals 2x plus 3, and you evaluate it at some value. In this case, we just did 2. Well, doesn't actually matter what that is. It could be more complex than that. So let's take a function like, we'll call it g of x equals x squared plus 4x plus 1. All right. Well, we could do g of 1. What does it mean when I do g of 1?
Wouldn't all the x goes to 1, meaning everything's like times 1?
Yeah, you just replace all of the x's with a 1. So you have 1 squared plus 4 times 1 plus 1. So what is 4 times 1? Anybody? 4 times 1. It's a tough one. So 4 times 1 is 4. So 1 plus 4 plus 1 equals 6. What about g of t? What do we get here? So you just replace everything in there with a t. So you get t squared plus 4t plus 1. It's as straightforward as that. Not doing anything crazy. All we're doing is taking what we are given as the function and literally just inputting the argument. We can also do something like g of x plus 2. This one's a little trickier looking, but it's no different. So all you do is you replace everywhere you see an x with x plus 2. So squared plus 4x plus 2 plus 1. It's the same idea, okay? So from here, and always, we need to simplify before we report an answer. So we actually have to multiply these things out. X plus 2 squared is x squared plus 4x plus 4 And then we have 4x plus 2. I'm sorry, 4x plus 8 plus 1. Combine everything together and you get x squared plus 8x plus 13. The point is you can evaluate a function with anything. The process just means you take whatever you're evaluating it at and you replace whatever the original one was. So it's just like a set of instructions. G takes any random thing, x, and it does this to it. So in the future, anything you put in there, this stuff will all happen to it. So let's see how we want to go. Another thing that we have kind of dealt with is finding the zeros of a function. And that just means to find where f of x equals 0. So if f of x equals x squared minus 5x plus 6, we need to find where does this thing equal 0. It equals 0. It's just the way we solve things in the past. You just get 0 equals x squared minus 5x plus 6. This factors into x minus 6. I'm sorry. Yeah, that's right. X minus 6, x plus 1. Nothing. So it factors into x minus 2, x minus 3. So x equals 2 or 3. So another common thing is setting two functions equal to each other. Let's see, we won't go through that. But when you set two functions equal to each other, you just then get one big equation. Let's do it. So if I said f of x equals, let's say 2x plus 5, and g of x equals x minus 2, then we can look for values where f of x and g of x equal each other. F of x but all this means is that we take this thing and set it equal to that one. So 2x plus 5 equals x minus 2. So pull everything together and you get x equals negative 7. So what we're saying is that f of negative 7 equals g of negative 7. Simple, straightforward as that. So this is just some things that you can do with functions, just shows that they follow basic mathematical rules. So let's talk about the domain of a function. Who can remind me what the domain of a function is?
It's the input or the x.
Yeah. So the domain has to do with the x, exactly right. And it's the allowed x values. So for the most part up to now, we've had we've dealt with functions that have, you can pretty much put any x value in that you want. So something like f of x equals 3x minus 5. You can put any x value from negative infinity to positive infinity in there and get something out. So this thing has an infinite domain. So the domain of this one goes from negative infinity to positive infinity. But what if we had something like something like this? What does the domain of this thing look like? Are there any values that you would not be allowed to put in here? So for finding functions, this thing cannot be 0 or less than 0, I'm sorry. So any value that makes this thing less than 0 is not in the domain. So 0 for x would work because that's positive. -1 would work. -2 would work. But anything lower than -2 doesn't work. So you go, I'm sorry, wrong bracket. you can go down to -2 inclusive up to positive infinity. Okay, so the domain just does not allow anything to be in the function that messes it up. It makes it go haywire. So sorry, notes. What about the domain of this one? Can you use any number? Are there any numbers you can't use? What numbers can't you use?
1 and negative infinity.
No, you could put -5 right here. You put -5, then this is 25 minus 4, which is 1/21, which is, it's a number. But what did we say you have to be careful of whenever you have a variable in the denominator? So when we were solving these rational equations, we said that you have to take out or discount any values of x that make the bottom 0. So anything that makes this 1 divided by 0 is bad. So you can put anything else in there except for those two. So that means that we definitely can go from negative infinity. And there's a couple ways you can write this. One of them is a little bit lazier. You say that you can put any number in there from negative infinity to infinity, except plus or minus 2. If you put 2 right here, you get 4 minus 4. If you get -2 right here, you get 4 minus 4. So you can't put -2 +2 because that would break this function, this equation, because you can't divide by 0. So this is the kind of idea with that you have certain values of x that you can't really use. All right. So let's see what this looks like in real life. Maybe not real life, but in graphical life. This is the idea. We're trying to go to graphs of functions. So if we talk about the domain and the range, actually, let's just finish up with that. We won't step ahead. So what is the range of a function?
The y and the
Yeah. Yeah, it's the list of values that you can get out. So let's use these same ones and do the range. So what is the range for this one? Okay, so again, lines, basic lines, can use every x value and every y value. Because there's nothing that could break that. Every time you put an x in, you'll get a y back out, and you can reverse it. So what about this one? What's the range of this one? So for a square root, the range is 0 to infinity. You can never get a negative number out of this square root. Everything is either 0 or positive. So here, last little one, what is the range of this? So this one is a little tricky, I guess. So there's only one value that is easy to see that you can't ever get from this.
0.
I'm sorry?
Zero.
Yeah, so one of them you can never get is 0. So what is the lowest value that you can get? So if you put in 0 for this, you get 1 over -4. You put in 1 for that, you get 1 over -3. So you can't ever get lower. I'm sorry. You keep going further negative